Hello. We'll wait for a few minutes. Hello. Okay. Hello. So we'll start now. So good afternoon, everyone. Up to sixth chapter we have covered, and today we are going to start our seventh and last chapter of switchgear and protection. That is over voltage protection. Right. So over voltage protection means there are different causes of this over voltage. So just wait a minute only. Hmm. ते काय आहे कीबोर्डला प्रॉब्लेम झालाय एक टाईप केलं तर डबलच टाईप होते Spelling पण yes. So the seventh chapter is over voltage protection. So there are different causes of this over voltage. We are going to see the different causes of this over voltage. So all of you know when we are considering any transmission line or any equipment we are using in our household applications. So for all these applications, sometimes there is a problem of over voltage, right? So actually our supply voltage is 230 volt AC. So what is the range of the voltage that can be increased or decreased? In what range we can increase or decrease the voltage, or if means there is no any effect if there is that much change in the voltage? Yes, what is that range? So voltages up to if we are considering the 230 volt AC as in supply voltage, then the voltage variation can be plus or minus 6. Okay, means we can increase or decrease voltage up to 6 volt only. Okay, up to 6 volt only. Then there will be no any effect on the equipment. Okay, but if that voltage change is beyond that limit, then your equipment get affected. Okay, so that may be over voltage or that may be the under voltage. Okay, so that's why we are using the stabilizer here. Okay, uh, and some for some equipments. Now, these over voltages are whatever we are seeing. These are related to the equipment protection also, and for the transmission line protection also. So, when actually such over voltages will happen or will occur, uh, so there are different causes of these over voltages. So we'll see some points for this. Now this chapter is very simple and very small. There are only 3 lectures for this chapter and we'll finish our syllabus. Okay. First of all, we'll see the contents of this unit. So the unit contents are the causes of over voltages. Okay, means which are the things due to which these over voltages occur. Then second is the surge arresters and absorbers. Means if these over voltages are occurring, they are affecting the regular or our power system. That's why we are using these surge arresters and surge absorbers, so that these over voltages can be limited and we will come to the normal position or normal condition. Then next is the metal oxide arresters. This is also one of the protective device. And last point is the insulation coordination in a system. Okay, insulation coordination in a system. So for this insulation coordination means how actually how when these over voltages will occur, what are remedies we can say we can use for this purpose. So these will be studied in this insulation coordination. Okay, now we'll see first point, that is the different causes of this over voltages. So can anyone tell me what are the causes? What can be the causes of these over voltages? Means why these over voltages are occurring in the power system? Can anyone tell me? Yes. Yes, anyone? What can be the causes for these over voltages? So everyone knows that sometimes what happens, the voltage get increased and our home appliances get damaged, right? So this happens many times. But what are the causes of these over voltages? Why this happens? Anyone? At least one? Yes, correct. The first is the lightning strokes. Correct, correct. Lightning strokes are there. Then anything else? Yes, anything else? Okay. So just tell me, we are considering the lightning strokes. So there are so many lightning strokes, means almost for uh, uh, for a minute, almost 100 lightning strokes are happening. Okay. So uh, why we are not considering all these? And uh, because they are occurring, but their length is not that much. Okay, means these lightning strokes are occurring, but they are not reaching to the earth. Okay, so those who are able to reach the earth, that can be only strike, that can only strike on these poles, that is the substations. Okay, means it is seen from the height. Actually it is striking the highest, or means food's height is more, there only it is striking, that is the lightning stroke, we can say. Then anything else which can cause these over voltages? Yes. Any other cause? Yes. I think diploma students can answer this. Okay, so we see one, there are actually two types of these causes. So what is mean by this over voltage? We'll see the causes of the over voltage in the power system. So increase in the voltage. Over voltage is nothing but the increase in the voltage for a very short time in a power system is nothing but the over voltage. So if any, for example, for your understanding, if any lightning stroke is there, lightning stroke means what? First tell me, what is mean by lightning stroke in Marathi? Second is insulation fails. Okay. What is mean by lightning stroke?
Waves.
Correct. So winds. So uh, these lightning strokes. So these are for a very short period of time. Okay, and when they strike on the highest uh, equipment, for example, pole, or for example, on any tree. Okay, when they hit that tree, hit that tree, that time we can say that there is a over voltage. So it is also called the voltage surge or voltage transient. Surge is nothing but an increase, okay, in anything. Okay, we know that there is a voltage surge. You may have studied this term in power system also. Voltage surge is there when you are seeing any waveform, and in between some in between that wave, somewhere it get high, right? That is nothing but the voltage surge. Okay, means voltage get increased there. So it is also called the voltage transient. Transient means some instability. Okay, instability due to that increase in the voltage. Okay, so this voltage stress caused by over voltage can damage the lines and equipments connected to the system. So it can damage the protect power system lines and also our equipments. Okay, so there are two types of this over voltage system, over voltage in this power system. First is the external over voltages, and second is the internal over voltages. Then what is mean by this external over voltages, and what are the internal over voltages? External, so whatever you told, that is the lightning stroke and insulation failure, these are the external over voltages. Okay, means these causes are external. Okay, so first we'll see the external over voltages. So these external over voltages originates from the atmospheric disturbances mainly due to lightning. Okay, uh, these are occurring due to the atmospheric disturbances mainly due to the lightning. Then this takes the form of a surge and has no direct relationship with the operating voltage of the line. Okay, so it gets suddenly increased and means it is not checking what is the line voltage for the transmission purpose or for the distribution purpose. Means it is not checking whatever be the operating voltage of the system. It is just increasing the voltage to its highest value. Okay, so there are different causes of these over voltages. First, external over voltages. First is the direct lightning stroke. Okay, direct lightning strokes means what? Direct lightning stroke. Okay, so actually, what is happening? What is happening? So when you are considering any cloud, okay, when you are considering any cloud of that uh, lightning, means there are different charges. Okay, there are different charges, and these charges are finding the path. Okay, because everything or the circuit get completed when the charge is flowing from its positive to negative terminal, right? So it wants to complete its circuit. Likewise, there are number of positive charges. Okay, so these positive charges want to circuit their complete their circuits. That why they are finding somewhere negative charge. Okay, or they are finding, or simply they want to complete their circuit. So that's why what happens, that uh, uh, direct stroke, in this direct stroke, that is the lightning discharge is occurring. Okay, so that lightning discharge is from that cloud. Okay, means it that cloud is nothing but the cloud of all the charges. Okay, that lightning discharge is from that cloud to that equipment. Okay, म्हणजे कुठून कुठे flow होणार, means it they want to complete their circuits. That's why they are finding some path so that they will reach to the earth. Okay, they will reach to the earth. Then that, so they are finding the tallest equipment. Okay, so which is the tallest equipment? If you see the transmission line towers, so they are very tall. Then they will find the tree. Okay, they will find the poles. Okay, so different types of poles of the electricity. So such equipments they are finding for completing their circuit. And for the line, so if we consider the line, that is the transmission line or a distribution line, so that current path can it can be along or over that insulators. Okay, means these lightning strokes are not only on the poles or on the trees or on the highest values, but if the transmission lines are also there. Okay, so for there also these lightning strokes are occurring, means they are hitting these transmission lines also. So when we are considering such lines, that time these voltages, these currents, that current path is along that transmission line, that is the over that insulators. Okay, and then it will down to the pole and then to the ground. Okay, so these are very high voltages, and they may cause the what we can say, the lightning or that flash over there. Okay, so there are again different types of these lightning, that is the direct stroke also. and indirect stroke also. Okay, so these are the lightning strokes. Okay, remember, these are the lightning strokes. So which are causing the over voltages. Then second is the electromagnetically induced over voltages due to lightning discharge taking place near the line called side stroke. Okay. So electromagnetically induced over voltages. So if due to this lightning discharge taking place near the line. So when that lightning stroke is discharging near the line, that is called the side stroke, or here the electromagnetically induced over voltages will be there. Then third is the voltages induced due to atmospheric changes along the length of line. Okay, means if uh, uh, means suppose mm, due to heavy rain, etc., or due to lightning strokes also. Somewhere near, if any environment get changed there, so some changes will be occurred there along the line also, along the transmission line also. So these are also these induced voltages are also very high. Then electrostatically induced voltages due to presence of charged clouds nearby. Okay, means if such charged clouds are near that line, then also there is electrostatically induced voltages. Okay, and last is the electrostatically induced voltages due to frictional effects of small particles like dust or dry snow in the atmosphere, or due to change in the altitude of the line. So these electrostatically, last type, these electrostatically induced over voltages are due to frictional effects. Actually, what is happening when we are considering the transmission line? So there is some distance between these lines, right? When we are considering, suppose R, Y, and B phases, there are three lines, right? For the one side. So when we are considering these three sides, so for these three transmission lines, or these three conductors, the air between them is acting as an insulator. But when mm, some frictional effects are there due to small particles like dust or dry snow. Okay, so in the atmosphere, or due to the change in the altitude of the line. So when that insulation get break there, and there may be some frictions due to this, so again there will be over voltages, and these are the electrostatically induced over voltages. So these all are the external causes which are causing the over voltages. Okay, now similarly, there are some internal over voltages. These are nothing but the causes which due to which these over voltage will occur. So these over voltages are caused by changes in operating conditions of the power system. So external, if due to some external effects, there is a change in or there is an increase in the voltage, and due to some change in the operating conditions also. Okay, means we are sometimes we are switching, right? Means every equipment or any transmission line is switched off or on. Okay, that time means while operating, some uh, there may be some increase in the voltage. So the first cause is the switching over voltages or the transient over voltages. This is the first type, and second is the temporary over voltages. So first, what are these switching over voltages or transient? Transient means for some time there is a change, means there is somewhat increase, means whatever stability of the system get means your system becomes unstable here. Okay, so this switching over voltages this is caused when operations is carried out under normal conditions or when fault occurs in the network. Okay, we know you know the different types of faults occurring in the network. So if any fault will occur in the power system, then also the voltage get increased. And when we are switching any line or any equipment, that time also under normal operating conditions, when you are switching any line or any equipment, that time also your voltage get increased. Okay, then when an unloaded long line is charged due to Faraday effect, the receiving end voltage get increased. So what is mean by this Faraday effect? Faraday effect. Yes, anyone? What is this Faraday effect? Anyone? What is the Faraday effect? In power system, you studied this. Amruta? Yes, anyone? What is the Faraday effect?
Voltage increases in a receiving end of the electrical transmission line.
Correct. The voltage get increased. Yes, you are very close. Then what is the sending end voltage? Yes. What is sending end voltage there?
Receiving voltage must be great.
Receiving end voltage. So the Faraday
Large.
effect is yes, correct.
large होता है.
Correct. So Faraday effect is your receiving end voltage becomes greater than the sending end voltage. Okay. Actually, when you are considering your normal system, that time your sending end voltage should be greater than your receiving end voltage. But here what happens in the Faraday effect? Your receiving end voltage becomes greater than the sending end voltage. Okay. Means what happens? This end side means your load acts as a source there. Okay. And your source acts as a load. Okay. So this happens when an unloaded transmission line is charged. म्हणजे काय होतं आपण म्हणजे एखाद्या सिस्टीमला लोडच दिला नाही आणि त्या लोड न देता आणखी एकदा आपण ती सिस्टीम चार्ज केली, then there will be then there will be the Faraday effect. Okay, so the system voltage means the receiving end voltage get increased here, resulting in over voltage in the system. So this will also cause the over voltage. And similarly, when the primary side of the transformers or reactors is switched on, over voltage of transient nature occurs. So when we are switching on the primary side of the transformers or reactors. Reactors are, you know, for filtering purpose, we are using the capacitors and reactors, right? So when these reactors or the transformers primary side is switched on, that time also the over voltages will occur. So these all are the internal causes for producing the over voltages. Okay. Then the second type is the temporary over voltages. So temporary over voltages means, for example, when any line, okay, get disconnected. Okay, any line get disconnected. So, means when some line means means actually we are sometimes what happens if any fault will occur. Okay, any fault will occur, so we are just disconnecting that line or disconnecting that load because there are number of generators, right? So what we are doing when any fault will occur, we are simply disconnecting that load or disconnecting that line. So it doesn't affect any other lines because these are supplied by other generators or other alternators, right? Because our transformer, so that transformer is continuously on, the distribution transformer for 24 hours it is on, right? That efficiency is low, but what is happening, we don't know what is the actual load required uh, for the supply. Means what is the actual load, we don't know. Means what actually the supply should be given, we don't know. That supply will change according to the morning's shift, according to the afternoon and evening shift. So we are just not disconnecting or we are not what we can say, just shutting down whole the transformer, that whole transformer. We are just shutting down these generators. Okay, so there are they are connecting in parallel and they are shut down, and according to the requirement only we are supplying. Okay, so when that load get disconnected, okay, from that long line, so under normal or steady state condition, so if that get disconnected, then again the voltage will increase. Okay, then so these are the causes of over voltages. First is the external and second is the internal. Now the next point is the surge arrestor. So what is mean by this surge arrestor? So we know that these voltages get increased. Then how to protect our transmission line and how to protect our equipments by using these different arresters. Okay, so how we can divert that voltage, or how we can uh, decrease that voltage so that our equipments get protected. So there are different arrangements or different equipments used here. So first is here the surge arrestor. So this surge arrestor is a protective device for limiting the voltage. Okay, so this is limiting that voltage, that over voltage on equipment by discharging or bypassing the surge current. So what happens when any suppose the lightning stroke is hitting that equipment, any equipment or any line, so that can be protected by using this surge arrestor. And what this surge arrestor does, this surge arrestor discharges or bypasses that surge current. Okay, so it prevents the continued flow to follow current to the ground. Okay, so what actually happens, that lightning stroke is striking some pole, some equipment or any line, so it is finding the path to reach the earth, right? It is finding path to reach the earth and it is finding the shortest path, right? Na? Just like the tree, means it is finding the tallest equipment, that is the tree or a pole. So when it will strike that, so immediately it will reach to the ground, right? So the flow of current is from that cloud of the full of charges, that is nothing but the lightning stroke, towards the ground, right? So this surge arrestor prevents that flow. Okay, it prevents that flow of current to the ground. Okay, so this lightning arrestor does not absorb or stop lightning. So there is one more equipment, that is lightning absorber. It actually absorbing this, but these lightning arresters are not absorbing or stopping the lightning. Okay, they are just bypassing or discharging that surge current. Okay, so it diverts the lightning, limits the voltage, and protects the equipment installed in parallel. So what it does, the surge arrestor diverts that lightning. Okay, means it gives some another path to that lightning stroke. It limits that voltage and protects the equipment installed in the parallel. Okay, installed in the parallel. So these surge arresters may have many applications, anywhere from the protecting a home to utility substation. Means these surge arresters can be used for protecting the home appliances also, and for the substation also. Okay, so they are installed on circuit breakers inside a residential home, on pole mounted transformers, on pole mounted riser poles and substations. Okay, so here these surge arresters can be located. Okay, and there are three classes of these surge arresters. First is the station class, second is intermediate class, and third is the distribution class. That is simply just the generating, transmission and the distribution. Okay, means according to the voltage levels or applications wherever we are using, uh, these are classified as the station, intermediate and distribution class arresters. Okay, so surge arresters. So any all of you can visit any substation. Okay, so if you visit the substation, you will come to know, or you can ask all the questions to that. So if it is possible to visit, all of you visit the substation, you will understand the whole power system, uh, and you can easily clear your concept. So when you study theoretically, all the concepts are not clear to you, but if you visit, you see how these equipments are connected, how these are working. Okay, so for example, if you are going and if you see any substation, then you should ask yourself, if you see that equipment, you should know what is that. Any question should be raised in your mind, that what is that, what is use of that equipment, right? So there are number of equipments in the substation, right? From transmission line, if you consider the pole, so I think you studied in power system only, right? So if you see that pole only for the transmission line, so there are uh, uh, means if you consider one string of that insulator, so if you see the number of discs, so you should know uh, what can be the voltage of that transmission line, right? So how many lines are there? What is the upper line showing? What are the left side and right side lines are showing? So all questions should be raised in your mind, and according to that, you should study the power system. Okay, it is practical oriented subject, and you should know these concepts, right? Then if you see the power substation also, then where are the insulators are used? Okay, means where actually these insulators are used or placed. If we are seeing here the surge arrestor, so where it is placed actually? So I'm saying something, and whatever you see, so there will be uh, means it will give you the deep knowledge, right? So if you see, you studied the transformers, but if you see the transformer at the substation, that transformer is of very high value. And again, all the parameters will get changed. So what can be the value of, means what can be the kVA rating of that transformer, or MVA? It is of course in MVA, right? So what can be the, what is the rating of the transformer? What equipments they are using? So you studied the construction of that transformer. So there is a conservator, transformer tank, oil tank, breather is there. So how actually they are working, right? So it should be studied, and there should be curiosity in your mind to study and to learn these things, because you are now in B, and in B you should study, you are studying the application oriented subject, so you should have the practical knowledge also. Okay, so the surge arresters are there. Then the next point is the surge absorber. So to protect these lines or any equipment from the over voltages, we are using these surge arresters and surge absorbers. So surge arrestor is doing what? It is bypassing that voltage and current, or it is diverting. Okay, it is not absorbing, but this surge absorber is a protective device used to absorb the complete surge, okay, due to the lightning surge or any transient surge in the system. So what the surge absorber is doing? It is absorbing that voltage. Okay, it is absorbing that voltage. So means just like uh, your oil as an insulator, right? So whatever heat produced by an arc, that heat is absorbed by that oil. So that's why it acts as an insulating material. Likewise, here this surge absorber absorbs that complete surge or that voltage. Okay, so it reduces the stiffness of wavefront of the surge by absorbing the surge energy. So stiffness of wavefront means what, actually what? So what happens when we are considering, or if suppose that when these lightning strokes or the voltage get increased, that increase is sudden. Okay, sudden increase means it is sharp, right? There is a sharp increase in that voltage. So uh, means your wave is not a normal. Okay, wave is not normal. So this stiffness of the wavefront, okay, means what I can say, means this is actually the slope. Means if I write here or draw here, the stiffness is low. The stiffness is low. But if there is a sudden increase, okay, that is nothing but the stiffness. So this surge absorber is reducing the stiffness of the wavefront. Okay, stiffness of the wavefront means that surge, that sudden increase in that voltage get reduced there. Okay, get reduced means this surge absorber is absorbing that surge energy. Okay, surge energy म्हणजे काय होतं, ओव्हर व्होल्टेज झाल्यामुळे ही काय आपली जी वेव्ह आहे ती इन्क्रीज होते. Okay, that is nothing but the surge. Surge is nothing but some increase. Okay, some increase, or we can say in Marathi फुगवटा. फुगवटा म्हणजे एखादं थोड्या वेळासाठी काहीतरी म्हणजे व्हॅल्यू इन्क्रीज झाली, that is we can say the surge. I don't know exact Marathi word, but so then the types of these surge absorbers, there are 3 types. First is the condenser or capacitor surge absorber. second is the inductor or and resistance surge absorber, and third is the Ferranti surge absorber. Okay, so we'll see here one by one. Okay, first that is the condenser or capacitor surge absorber. Capacitor surge absorber. So here it is very simple. So here what we are doing, so consider a transmission line, one transformer is there, and we are connecting one capacitor here or the condenser, and it is connected to the ground. Okay, so we are connecting this capacitor between this line and the ground. So this capacitor is used as a surge absorber to protect the transformer winding. So since the reactance of the condenser is inversely proportional to the frequency, right now? Right or wrong? And how it is? How the reactance of the capacitor or condenser is inversely proportional to the frequency? What is the equation? What is the equation for the reactance? Yes. What is the equation for capacitive reactance? Yes, anyone? The equation for inductive reactance? Yes, guys, very basic, from basic electrical engineering only. Yes. Kiran, Deepak,
X is equal to 1 by 2 pi FC.
correct. So equation is capacitive reactance is Xc is equal to 1 divided by 2 pi Fc. 2 pi Fc means here the frequency is inversely proportional to the capacitor reactance, and it will be low at high frequency. Means if the frequency increases, your capacitive reactance decreases. Okay, so these the surges are of high frequency. Okay, when the voltage will increase, these voltages means these voltage surges are of high frequency. Therefore, capacitor acts as a short circuit. Okay, how it acts as a short circuit? Because if the frequency increases, the reactance becomes very low. And if the reactance is nothing but the resistance here for the capacitor. So this becomes very low and almost zero. And when this reactance becomes very low, means your capacitor will act as a short circuit and passes them directly to the earth. Okay, so when over voltage will occur, what happens? They are having very high frequency, and due to that high frequency, the capacitive reactance becomes very low, almost zero, and the capacitor acts as a short circuit, and whatever be the current flowing through that line or which is connected to the transformer, so that current will flow towards the earth only. Then what happens? The current flowing through that transformer becomes very low. Means in this way, this capacitor here, the absorbing that the voltage surge or the surge produced due to over voltages. However, the power frequency, the reactance of the capacitor is very high, and practically no current flows through the ground. So if we are considering the power frequency, for power frequency, the reactance is very high. And if the reactance is high, means the resistance is high, the current flowing through that capacitor will be very low, means the current will not flow towards the ground, right? So in this way, in this condenser or capacitor surge arrestor, your capacitor is absorbing that surge, okay, or absorbing that increased voltage, and that will be passed to the ground, okay. Then the second type is inductor and resistance surge absorber. Inductor and resistance surge absorber, okay. So inductor and resistance means we are using here both. So here you can see one inductor and one resistance. These are connected in parallel. So this inductor is nothing but the choke. Okay, inductor is nothing but the choke. So both are connected in parallel to protect the transformer. Now, as here we are considering the inductor, we have to consider the inductive reactance. Now, here it is already given. The inductive reactance XL is equal to 2 pi FL. I think everyone knows this equation. So here you can see that this XL is directly proportional to the frequency. Means if the frequency becomes higher due to increase in the voltage or due to the surges, if frequency becomes more or frequency increases, that time this XL means the inductive reactance should what if the frequency increases, that time this inductive reactance also get increased there, okay. Inductive reactance also get increased. Then to decrease that reactance, okay, to decrease that reactance, what we have to do? Yes, anyone, what we have to do? Because that reactance will get in, if you decrease the reactance, then of course your frequency will also get decreased, right? No? So what we can do there? Yes, anyone? Okay. So here, concentrate. Now here, what happens when that voltage get increased? Okay, when the voltage get increased, your inductive reactance also get increased. And when the inductive reactance will get increased, now the current will not flow towards the earth. Then we have to provide one more path so that the current there will be a very high current that should be flowed towards earth. The another path is provided here, that is nothing but one resistance connected in parallel. Now through that path your current will flow towards the earth, okay. So means that is absorbed by this surge absorber, that is nothing but the inductor and resistance surge absorber. This simply we are connecting different equipments, that is the capacitor, inductor and resistance, okay. So first two we have seen. Now one more last, that is the Ferranti surge absorber, okay. Ferranti surge absorber. So here we are considering one coil, okay. That is nothing but one inductor, but the difference is that here we are using this air core, okay. The air core inductor we are using, and This okay. Hello. Sorry, there was a call. So here this is an air core inductor, and this inductor is placed in one cylinder. Okay, one cylinder shape. Okay, and we are again protecting here the transformer, and that cylinder is earth here. Okay, so it consists of an air core inductor connected in series with the line. Okay. Then this inductor is insulated from an earth metallic cylinder called the dissipator. Okay, means this inductor means we are using this cylinder, but this means this inductor is insulated from this metallic cylinder. Okay, and this arrangement equivalent to a transformer with short circuited secondary. Okay, so uh, I think you studied in electrical machines when we are shorting the secondary side of the transformer. So here the inductor acts as a primary of transformer, and this dissipator means that cylinder acts as a short circuited second consumed in the dissipator in the form of heat due to transformer action. Okay, so when the over voltage will occur, when the over voltage will occur, that energy means energy of that surge is consumed in this dissipator, means in this cylinder in the form of heat due to the transformer action, because this acts as a short circuited secondary. Okay, short circuited secondary, and that will be given to the earth now. Okay, that will be given to the earth. So that is the Ferranti surge absorber here, and this is used for the protection of transformers. Okay, so here we have completed first 2 points, that is the causes of the over voltages, and second is the surge arresters and surge absorbers. Okay, in tomorrow's lecture we'll see the next point. Okay, so for today we'll stop here. Thank you all and have a nice day. Thank you.